Hi all, welcome to my YouTube channel again. Today we are going to learn about the divisibility rule for 3. It says that a number is exactly divisible by 3 if the sum of its digits is exactly divisible by 3. Let us understand the rule with an example. Example: is 123 exactly divisible by 3? Check the rule. First, find the sum of digits. Here, the digits of 123 are 1, 2 and 3. So, the sum of digits equals 1 plus 2 plus 3 gives you 6. Next step, is 6 exactly divisible by 3? Check it. We know that 3 twos are 6. You got 0 as the remainder. When the remainder is 0, we say that the dividend is exactly divisible by the divisor. So, 6 is exactly divisible by 3. Got it? Therefore, according to the rule, 123 should be exactly divisible by 3. Now, let us verify the correctness of the rule by using long division. When we divide 123 by 3, we get 0 as the remainder. When the remainder is 0, we say that the dividend is exactly divisible by the divisor. So, 123 is exactly divisible by 3. Hence, the rule is satisfied. Got it? Let us move on to another example. Is 247 exactly divisible by 3? First, find the sum of digits. The digits of 247 are 2, 4 and 7. So, the sum of digits equals 2 plus 4 plus 7 gives you 13. Next, check. Is 13 exactly divisible by 3? When we divide 13 by 3, we get 1 as the remainder. When the remainder is not 0, we say that the dividend is not exactly divisible by the divisor. So, 13 is not exactly divisible by 3. Therefore, according to the divisibility rule for 3, 247 should not be exactly divisible by 3. Got it? Now, verify the correctness of the divisibility rule using long division. When we divide 247 by 3, we get 1 as the remainder. When the remainder is not 0, we say that the dividend is not exactly divisible by the divisor. So, 247 is not exactly divisible by 3. Hence, the divisibility rule for 3 is satisfied because it already said 247 should not be exactly divisible by 3. Got it? Thank you for watching. Hope you enjoyed. Please like, comment and subscribe to my channel Basics to Master Maths. Thank you.